This video is going to look at proportional relationships. Proportional relationships all have a constant rate of change. A constant rate of change means that it changes by the same amount each time, which means that the slope is also constant. Remember that slope is our rise over our run. It's the change in the y compared to the change in the x. A proportional relationship also has to start at the origin point. It has to go through 0, 0. So when we're talking about a graph, if it's a proportional relationship, it has to go through this origin point in order for it to be proportional. It has to have a 0, 0 starting point. So let's look at this example. This graph is showing us the time in weeks and the amount of money in savings during that time. At the top, it reminds us that slope is the change in the y compared to the change in the x. We could say that it's the change in the dependent variable over the independent variable. Remember that x is our independent variable, which is the one that we can't change. So in this example, on the x-axis we have time. So the time is our x, and the savings is what is changing, which is our y. So first we use our graph to complete the table. We have 0 at 0, 0 weeks at $0. I see 10 weeks at $40. I see 15 weeks at, let's say about $60. And then we have 25, and it looks like it's going at about $100. So I'm going to put it at $100. So that's 25 weeks and $100. So I'm going to choose different points to find the slope, and remember I'm looking at the y over the x. So I'm saying how much does this change, the savings, compared to how much this changes in the time. The savings, the difference between 40 and 60 is 20. On the x, the difference between 10 and 15 is 5. If I simplify that, we would say that the slope is 4, or we could say that the unit rate is 4, which means that it's $4 per week. If I tried to look at this one right here, I can figure out that this is changing by 40, and this is changing by 10, and that simplified also gives us a slope of 4, so $4 per week. So in these examples, we're looking to see if these are direct variation relationships or if they are proportional relationships. Direct variation just means that it is a proportional relationship. And so we're looking just to see if they are proportional relationships or not. So when I look at the first one, I'm looking at the change between them. If I look at the change in the at-bats, I get 31. The change in the games is 10. Remember, I'm putting my y over my x, so my at-bats is going over my games. If I go to the next one, if I look at the change here, the top or the x changes by 20, the y changes by 62. So some people would say it's not a direct variation, but if you simplify 62 over 20, so let's say I divide it by 2. If I divide it by 2, I get 31 over 10, which means it's changing at a constant rate. So we would say that yes, it is proportional because it's changing at a constant rate. Our next example, I'm going to look again to see if it is proportional or direct variation. The difference between 15 and 8 is 7. The difference between 300 and 160 is 140. So if I write that as my change in my y to my change in my x, I get 140 over 7, which simplifies to 20. Then I'm going to look at the next one, and I'm looking at the change in my y. So from 300 to 560, that changes by 260. And then from 28 to 15, that changes by 13. And so I wasn't sure if that was a direct variation or not, so I went ahead and divided it in my calculator, and I got 20, which means that yes, this is also a proportional relationship. If it's proportional, it has a 0-0 relationship and it changes by a constant rate. This one wants us to write an equation. The number of cups in a measure varies directly as the number of tablespoons. Write a direct variation equation that describes the relationship. Then use your equation to determine the number of cups in 56 tablespoons. So first I want to remind you of our equation. Our equation is y equals mx plus b. If it is a proportional relationship, which this one it looks like it is, when it starts at that 0, 0, my plus b should be 0 because proportional won't have that part right there. So we're looking at finding what the slope is. That's our m. And then it wants us to substitute 56 in. So I'm going to take this graph and make it into a table. So x is going to be our tablespoons. And y is going to be the number of cups. And so when I look at x, when x is 4, then y, or the number of cups, is 0.25, or 1/4 of a cup. When x is 8, y is half of a cup. When x is 12, I'm going to run out of room, then y is 75 hundredths of a cup. And then it skips and it goes to when x is 20, the y is 1 1/4, or 1.25. So that's our data from our graph into a table. So when I look to see what's happening, I look at my change. When I look at my change, it's changing by 25 hundredths each time, and this is changing by 4 each time. So my change in my y would be 25 hundredths. My change in my x would be 4. If I simplify that to a decimal, I'm going to get decimal 0.625. So that's our constant rate. That's our change each time. So in an equation, we could write y equals 0.0625x, and that would be our equation. Then it wants us to estimate the number of cups in 56 tablespoons. So I can substitute 56 in for the x to figure out how many cups 56 tablespoons would be. When I do that, I get 3.5. So 56 tablespoons is 3.5 cups. These are the 3 questions that I'd like for you to try and come check with me for understanding. You may write them on your own paper or on a whiteboard. Make sure that you show your work of how you determined the slope and your equation on the third one. Make sure you check with me before moving on.